In this video, we're going to talk about differentiation and integrals of parametric. If you want to find the first derivative, dy over dx of a parametric, that will equal to dy over dt over dx over dt. And the second derivative will be dy prime over dt over dx dt. But I prefer to use taking the derivative of dy over dx respect to t on top, and it will be over dx dt. Let's take a look at some examples. So it says, consider the curve defined parametrically by x equals t squared minus 5 and y equals 2 sine t for where t goes from 0 to pi. Part A says, sketch a graph of the curve in the viewing window -7 to 7 by -4 to 4, and it says indicate the direction in which it is traced. So we need to use graphing calculator to do part A. So you need to put x as t squared minus 5 and y 1 as 2 sine t. And when you go to window, t minimum is 0 and t max is pi, since we're going from 0 to pi. And your x minimum is -7, x max is 7, and so forth, -4 and 4. So let's graph and see what happens. As you can see, it drew really fast. Make sure you use your own calculator, and you will notice that it went this way. So when you sketch a graph, your graph should look something like this. Make sure you have a direction indicating that the graph was going this way. Now, part B says find the highest point on the curve and justify your answer. When they want you to find the highest point on the curve, it's around here. And notice, parametric has x and y values. So basically, we're looking for the maximum of y, since we're looking for the highest point. If it said furthest to the right, then you probably have to find the maximum of x. But since we're looking for the vertical distance, we need to work with y value. So y is equal to 2 sine t. And let's take the derivative of y with respect to t. So dy dt is equal to 2 cosine of t. Now, since you want to find the maximum, you want to set that equal to 0 and solve for t. So let's divide both sides by 2. You're going to get 0 equals cosine t. Now, notice the domain of t is 0 to pi. So cosine of what gives you 0 from 0 to pi? Well, that's when t is equal to pi over 2. Because cosine of pi over 2 is 0. So let's draw the line. This is dy over dt. We're going from 0 to pi. And you have a pi over 2 as a critical number. Now, let's plug in a number. Nice number between 0 and pi over 2, which is like pi over 4. When you plug in pi over 4 over here, you'll notice that dy over dt is positive. What about over here? What is a nice number that you could choose over here? Choose a number between pi over 2 and pi and plug in for t. You'll notice that it will be negative. So the maximum will occur at pi over 2. Another way of looking at it is you could use a graphing calculator. You could draw 2 cosine t. So using a graphing calculator, we're going to graph 2 cosine of x. And notice, it's no longer parametric. I'm using function as my mode. And I'm going to go to window. My x minimum will be 0 and x max as pi. And my x scale will be pi over 2. And when you graph it, you get something like this. So this is a graph of 2 cosine of x. And notice, this is going to be pi over 2. You could double check it by finding the x-intercept. And from 0 to pi over 2, the graph is above the x-axis, which means that 2 cosine of x is positive. And from pi over 2 to pi, 2 cosine of x is below the x-axis, which means it will be negative. So using our graphing calculator, it matches our analysis over here. Now, we need to find the highest point on the curve. So what we need to do is, since the highest point occurs when t equals pi over 2, because sign changes from positive to negative, we got to plug that t, pi over 2, to over here. And when you do that, when you substitute pi over 2 instead of t, you will get x as around negative 2.533, comma, the y value will be 2. So the highest point on the curve happens approximately at negative 2.533, comma, 2. Now, part C says find all points of inflection on the curve. Justify your answer. So in order to find the points of inflection, we got to find the second derivative of the parametric. In order to find the first derivative, dy over dx, that will equal to dy over dt over dx dt. So that means we need to find dy over dt and dx dt. And since y is equal to 2 sine t, you know that dy over dt will be 2 cosine of t. And since x equals t squared minus 5, dx over dt will be 2t. Therefore, dy over dx is equal to 2 cosine of t over 2t, and 2 cancels out. You end up getting cosine of t over t. That is the dy over dx for this parametric. Now, in order to find the second derivative, what you need to do is you got to take the derivative of dy over dx respect to t over dx dt. And we know what dx dt is. That is 2t. So what we need to do is we need to take the derivative of cosine of t over t respect to t and then put it over 2t. So in order to find the derivative of cosine t over t, we have to use a quotient rule. So what you need to do is you need to do denominator square. And then it's going to be the denominator times the derivative of numerator, which is negative sine t, minus the numerator times the derivative of denominator, which is just 1. So it's going to be negative t sine t minus cosine t over t squared over 2t. So when you clean this up, when you simplify this, you will end up getting negative t sine t minus cosine t all over 2t to the third power. So this is a second derivative. Now you know that concavity happens when the sign of the second derivative changes sign. So basically we need to come up with the analysis, but this is kind of complicated. So what we're going to do is we're going to use a graphing calculator and graph this, and we're going to use that to analyze the second derivative. So put your second derivative into your calculator. Again, now the mode is in function, not in parametric. And make sure your window is from 0 to pi for x values. And let's graph it. Now when you graphed it, it doesn't look like there is a x-intercept. Let's change your window. So y minimum, let's change it to negative 0.1 and y maximum to 0.1 and see what happens. So now you can see that there is a x-intercept, and this part right here indicates that second derivative is negative because it's below the x-axis, and this part indicates that the second derivative is positive since the graph is above the x-axis. So let's find this value. Second, trace for calc, press number 2 for 0, left bound. Let's click enter, and then right bound. Make sure it's above the x-axis. Press enter and enter again. So there is your 0, 2.798386. And this means it's approximately 0. That's 10 to the negative 15 power. So now we know that the inflection happens when t equals 2.798386. And concavity changes because second derivative, when t equals this value, second derivative changes from negative to positive. Since x equals t squared minus 5 and y equals 2 sine t, we know that the inflection point will happen at this point on the curve, and we got this value by substituting this value to the original. Now you should try it on your own with your calculator to make sure that you get these values. Now to find the arc length of a parametric curve, what you need to do is you got to take the integral of square root of quantity dx dt squared plus quantity dy over dt squared from t1 to t2. Now the common mistake is students forget to put dt, which is outside the radical. So don't forget to put dt as a setup. And now let's take a look at example. So it says find the length of the asteroid, where x equals quantity cosine t to the third power, y equals quantity sine t to the third power, and t is going from 0 to 2 pi. So when you graph this parametric using your calculator, this will be your setup. And when you try zoom standard, it looks too small. So what I like to do is probably go to zoom, fit, press 0, and you get a nice graph. And make sure you go to window, see if you're going from 0 to 2 pi, because that was our domain for t. So what you're doing is you're finding the total length of this curve from 0 to 2 pi. That's what we're trying to do. So in order to do that, we got to find dx dt and dy dt. So I like to first rewrite x as quantity cosine t to the third power and y equals quantity sine t to the third power, so that it's easier to find the derivatives. So dx dt is going to be 3 quantity cosine t squared times the derivative of inside, the chain rule. And dy over dt is going to be 3 quantity sine t squared times the derivative inside, which is cosine t. So your setup will be integral from 0 to 2 pi of square root of dx dt squared. Notice I just substituted this quantity over here, and plus quantity dy dt squared, which will be this. And of course, don't forget the dt, which is outside the radical. Now, doing this by hand will be very complicated. So what we're going to do is we're going to use our graphing calculator. So when we use our graphing calculator, I'm going to say this is my y1. Your dx dt is going to be your y1, and your dy dt is going to be y2. So this is your y1, which was dx over dt, and this is your y2, dy dt. Now again, I'm not in the parametric mode, I'm in the function mode. So make sure you go to mode and change back to function. So now what we're going to do is we're going to go to the home screen and choose math, and we're going to do the function integral, number 9. So we're going from 0 to 2 pi, and we're going to put radical, and then it has to be y1 squared, so we're going to go to alpha trace, choose y1, which is number 1, square, plus y2, so alpha trace, choose y2, square, and then make sure you get out and choose x, and then press enter. And you'll notice that our answer is 6. So therefore, our final answer is 6. Now on the AP exam, they want the setup in this format, but when you get your answer, they allow you to use calculator and get the final answer. But make sure you show the setup this way. Don't use the calculator syntax.